Hey there, welcome back. What's on your mind today?
Read this article.
Sure, the article is about the Nobel Prize in Physics for 2025, awarded to John Clark, Michael Deveray, and John Martinez. They conducted experiments with superconducting circuits, specifically using a setup called a Josephson junction. Their work demonstrated quantum behaviors in these macroscopic systems, showing how they can absorb or emit specific energy amounts, in line with quantum mechanics. The article highlights the relevance and surprises quantum mechanics continues to offer, being a foundation for digital tech.
Okay, continue reading.
The Nobel Prize in Physics for 2025 was awarded to John Clark, Michael Deveray, and John Martinez. Their groundbreaking experiments in the 1980s with superconducting circuits led to novel insights into quantum behaviors. They used a specific setup called a Josephson junction, allowing them to control and explore the quantum phenomena of a macroscopic particle-like system. Their research showcases how quantum mechanics continues to surprise and underpins all digital technology.
Okay, continue.
Continuing with the article, Clark, Deverett, and Martinez demonstrated the quantum behavior of a macroscopic particle-like system. Initially, the system remains in a zero-voltage state, appearing trapped behind a barrier it can't cross. However, the system shows its quantum character by escaping this state through tunneling, confirmed by the appearance of a voltage. Their work highlighted that their system behaves according to quantum mechanics, absorbing or emitting only specific energy amounts.
Okay. What do you conclude from this?
The article announces that John Clark, Michael Deverett, and John Martinez won the 2025 Nobel Prize in Physics. Their work in superconducting circuits, particularly the Josephson junction setup, demonstrated how macroscopic systems can exhibit quantum behavior. This achievement highlights the ongoing surprises and foundational role of quantum mechanics in digital technology.
Come again?
Sure, the press release announces the Nobel Prize in Physics for 2025, awarded to John Clark, Michael Deveray, and John Martinez. Their groundbreaking work involves superconducting circuits and Josephson junctions, demonstrating quantum behaviors in macroscopic systems. Their achievements highlight the profound impact of quantum mechanics on digital technology.
Okay. Now, what is quantum behavior compared to digital technologies?
In contrast to digital technologies that mainly rely on classical physics principles, the research by Clark, Deverett, and Martinez explored quantum mechanics, revealing behaviors not observable in everyday digital tech. Their work with superconducting circuits and Josephson junctions demonstrated quantum properties in macroscopic systems, a stark contrast to the classical physics principles that digital technologies depend on.
Okay. Thank you.
You're welcome.
Just one question. What is quantum behavior?
Quantum behavior refers to the unique and often non-intuitive properties exhibited by particles at the smallest scales, like atoms and subatomic particles. It includes phenomena such as superposition, where particles can exist in multiple states at once, and entanglement, where particles separated by large distances instantly affect each other. Quantum behavior is fundamental to the field of quantum mechanics, and underpins technologies like quantum computing.
Where quantum mechanics is used.
Quantum mechanics is used in various fields, like quantum computing, for processing information exponentially faster than classical computers, and quantum cryptography for ultra-secure communication. It's also vital in developing advanced materials and understanding fundamental physics in fields like superconductivity and particle physics.
Okay. Thank you. Today we stop here and tomorrow we read the rest of the article. Okay, other articles.
Unfortunately, I can't read the other articles in this screenshot. I'd need a closer look to help you with those. Could you provide more details, or perhaps share the specific article you'd like information on? Hey, good to have you back.
Hi. I have shared this screen, so read this article.
The article discusses a Nobel Prize-winning physics experiment. It explores how Cooper pairs, which are electrons behaving as a single entity, show quantum behavior. The system's energy levels are quantized, meaning energy is divided into set amounts or quanta. Microwaves introduced into the system move it to higher energy levels, showing the shorter duration in higher energy states. This experiment offers insights into quantum mechanics, especially in demonstrating quantum effects on a macroscopic scale.
Great. You completely read this article. Let us move on to the next article. Okay.
Sure, let's make. Welcome back.
Can you read?
Sure, I can read this. The article from the Royal Swedish Academy of Sciences discusses the phenomenon of quantum tunneling. It highlights how at low temperatures, the escape current distribution might be determined by macroscopic quantum tunneling. The article also mentions the need to eliminate excess noise for a decisive proof of this phenomenon, and compares experimental results to theory.
Come again?
Of course, the article details Nobel Prize-winning research in physics, demonstrating quantum properties on a macroscopic scale. The researchers experimented with superconducting circuits, showing that quantum tunneling can be observed on a scale large enough to be held in hand. The experiments involved a system that could tunnel from one state to another and absorb and emit energy in specific quanta, aligning with quantum mechanics predictions.
How the quantum behavior takes place in macro scale.
The article in the Microsoft Edge window mentions that the Royal Swedish Academy of Sciences awarded the Nobel Prize in Physics for 2025 jointly to John Clark, Michel Deverett, and John Martinez. It's likely related to advancements in quantum physics. Would you like me to delve into any specific section?
Okay, I will look into it. So you have read this much. Let me verify what you have read is correct in next session. So there are a lot of equations that it has mentioned in this article that we have to verify, and there are many things we have to check on this. It's a 13-page article. So can you elaborate a little bit on the equations what they have mentioned here? Can you read that?
The article from the Microsoft Edge window discusses a physics experiment related to superconducting junctions and their applications, notably in sensitive magnetometry and bolometry. Researchers, including John Martinez and Michel Deverett, conducted experiments that confirmed macroscopic quantum tunneling. They used a carefully designed filter chain to dampen frequencies and a microwave control line for resonant activation of the junction. This allowed them to measure escape rates below the crossover temperature, aligning with theoretical predictions.
Okay. Thank you, Copilot. That much for today. We'll resume it next session. Okay. Thank you.
Welcome back. Let's dive into something new. What are you curious about today?
No, I'm ending this session, YouTube session today, and we resume this session in the next session. Okay.
Got it. We'll pause here and pick up in the next session. Looking forward to it.